In this tutorial, we're going to take a look at a lot of the geometry of lines and polygons, big ideas or important concepts in the grade 9 academic course. And we're going to talk about in this page some properties of parallel lines and when a line cuts through them. So the red pair of lines in all three diagrams here are supposed to be parallel. That's what the arrows means in each diagram. This line that cuts through is called a transversal. That's the name of it. And so we're going to look at properties of angles when that cuts through. And so first of all, in this first one here, and this is just an example, these angles right here, now they're the angles between the parallel lines and on the opposite side of the transversal. Those two angles would be equal. And this is called the Z pattern by a lot of people because if you can, so here's the Z, what it looks like. So when you draw a Z, that angle and that angle right there, they're the alternate angles, and they are always equal, of course, as long as these two lines are parallel. If they're not parallel, then that goes out the window. This angle right here and this angle right here would also be equal. That's another pair of parallel, equal alternate angles. So that would be kind of drawing the Z backwards like this. Okay, but they would still be equal. The reason I know that's 102 is because this 78 and that one make together a straight line. And straight line's 180 degrees. So 180 minus this would be 102. 180 minus this would be 102. So this is 102 over here as well. So that's the alternate angles. Now, corresponding angles are equal. This is called the F pattern. So a same diagram is over here. So there's 102 degree, and you see if that's 78, then this angle down here would be 102. Again, those two make a straight line, straight angle. So 78 subtracted from 180 is 102 down here. So and here's what the F looks like. So this angle and this angle are said to correspond, and they are always equal, again, as long as these two lines are parallel. There's other pairs of corresponding angles too. There's actually more than just one or two. There's actually 4 pairs. So here's another one here. See, this would be 78, and so would this one. Again, those two add to 180, those two add to 180. So here's the F, and I've kind of drawn it backwards, but that's the same idea. So that's another pair of corresponding angles. Similarly, this angle here corresponds to this one. They would both be 102. And this 78 here and this 78 here are also equal. They're said to correspond, and that's another F pattern, kind of upside down, but they are corresponding as well. Last one here, and I'm using the same 78 and 102, but I've highlighted these two. So these are the two angles between the parallel lines, but in this case they're both on the same side of that transversal. So the 102 and 78, notice that they add up to 180. These are pairs that aren't equal, like they are in the corresponding or alternate pattern. But these two angles are supplementary. They add up to 180 degrees. Similarly, and of course this is what the C looks like. Okay, so there's the C, kind of straight sides, but it's supposed to be C. Similarly, see, this would be 102, this would be 78. They would add up to 180. So that's the C pattern. So flipping over to the second page, a polygon is any figure with straight sides. And so we've referred to the whole group of them as n-sided polygons. It could have 3 sides and be called a triangle. It could have 4 sides and be called a quadrilateral. It could be 5 sides, 6 sides, 10 sides, decagon, whatever. So this formula for the sum of the interior angles applies to all of them. If you have a triangle up, it doesn't matter how many sides it has. The sum of all the inside angles, interior angles, is the number of sides minus 2 times 180. And I'll talk about why the n minus 2 in a moment when we get into this first example here. So for example, if we had a triangle, we'll take the, of course, this is the smallest value n could be. You can't have a polygon with 2 sides or 1 side. Okay, 3 sides is the smallest. So we want to, if you didn't remember that it's 180 degrees, we put 3 in the formula right here. So 3 minus 2 times 180. So remember, order of operations, 3 minus 2 has to be done first. So that's 1. So 1 times 180 is 180 degrees. So the interior angle sum of a triangle is 180 degrees. So in this first example, we're asked, what is the size of each interior angle in a regular hexagon? Now, hex means 6 sides. And regular means they're all the same. So I could have put a mark here, okay, and said that all those sides are the same. Now, if all the sides are the same, then all of these angles are also the same. So here's our interior angle sum formula, and it's a 6-sided figure, so we're going to put 6 in place of n. 6 minus 2 is 4. And so we multiply 4 by 180, and the interior angle sum is 720 degrees. And since it's regular, they're all the angles are the same, so we divide the 720 by 6 because there's 6 equal sides, and we get 120 degrees. And so this is what it looks like. They're all 120 degrees. Now I said I'd mention about the n, why it's n minus 2, and I'm going to just back this up for a second and take this 120 off. If you ever forget the formula, and you can't remember, what is it, n times 180, n minus something times 180, take your figure, so I'm going to use the hexagon here, and divide it into triangles. And I'm doing this freehand, so this is not going to be very straight. Just the second one, really. So I divided it into triangles. Notice that there are 1, 2, 3, 4 of them. Okay, so 6 sides. There's always going to be 2 less than the number of sides triangles. So that's why it's n minus 2. See, that 4 I just counted is actually this 4 right here. See, each triangle has an interior sum of 180 degrees, so see, this one adds to 180, all the angles inside, and this one, the sum is 180, and they all are. So that's why there's 4 180s to make 720 degrees. So if you ever forget the formula, that's what you can do to find the interior angle sum. Now another property, and this relates to example 2 here, and it doesn't matter, and okay, there's my 120s again. The exterior angle sum for all polygons, 3 sides, 10 sides, 20 sides, doesn't matter, is always always 360 degrees. So if we extend these sides, extend them, see there'd be 6 exterior angles up here, and they always add up to 360. It doesn't matter how many sides you have, a triangle, quadrilateral, hexagon, it always adds up to 360 degrees on the outside. And so in example 2 it says, what's the size of each exterior angle in this regular hexagon? So the simplest way to do this is to take, actually I'm going to show you 2 ways. We could just take the 120 away from 180, because see, these 2 angles right here add up to 180. They make a straight angle. So 180 minus 120 would be 60. Okay, so if you could look at each one, as long as you know the interior angle, then subtract that from 180, gives you the exterior angle. So they're all 60 degrees. Now, if we hadn't done this up here in example 1, and you didn't know that these were 120s, what you can do instead, and I guess this only works if it's a regular polygon, you could, for each exterior angle, is take that sum and divide it by the number of angles. So there's 6 sides, so there's 6 exterior angles, so they're each 60 degrees. So this calculation, you don't need to know that 720 sum first and there's 120 inside. That would work for any regular n-sided polygon. Okay, so if you had a 20-sided one, we would divide, and it was regular, of course, 360 by 20 to get the exterior angle, and you wouldn't need to know what the interior sum is. Example number 3. And this is another property of triangles you should be familiar with. Points D and E are the midpoints of these 2 sides. Side AB's midpoint is D, side AC's midpoint is E, and we're asked how long is side DE. Now, if you connect those midpoints, then there's something special about this DE side and the side in the big triangle across from it. Since those are the midpoints of AB and AC, then this DE, by connecting them, we make a side parallel to this and half the length. So this point joining the 2 midpoints is half the length of this side out here. So this is 10.2, then DE would be 5.1 long. So it's parallel and half the length, or I guess you could say that BC is parallel to this and BC is double the length of that one. You can say it both ways. Example number 4 says determine the value of r in the diagram below. Another question you'll see on the EQAOs a lot is you've got a polygon with, in this case, it's 4 sides, and you're told 3 of the angles. So you'd have to know or be able to find out all the angles but the one you want to find. So here's an 80, 115, and of course that's 90. Don't forget about the 90 here. And we're trying to find this angle r. Well, the interior angle sum, if you don't know for quadrilateral, is 4 sides. So 4 minus 2 is 2 times 180 would be 360. So these 4 angles should add up to 360. So if we add up the 80, the 90, the 115, and the r, all of them should add up to 360. So I'm going to add up the 80, 90, and 115. Those add to 285. And so to find r, we would subtract 285 from 360. So angle r should be 75 degrees. Now, I see a lot of people doing this without using an equation. That's not a big deal. I see a lot of people who actually write down 115 plus 90 plus 80 is 285, and then show they subtract it from 360, and that's fine. There's nothing wrong with that at all. But I'm just demonstrating how it can be done with an equation. Example number 5. Determine the value of x in the diagram below. Now it kind of looks like in this triangle, we're trying to find x, that we don't know 2 of the angles. We don't know the x and we don't know this one up here. But when I phrased that in the previous question, we can find what this angle is, and then we can find what x is. See, up here, this is a right angle. So the whole angle that goes around from here, that's 90. And if we're told this much is 20, then this angle up here we could find by subtracting 20 from the 90. So that angle right there would be 70 degrees. So now we know 2 of the angles. There's only one we don't know, so we can find angle x. So the x, the 38, and the 70 add up to 180. Those 2 together add up to 108. And so we take the 108 away from 180, and x is 72. Example number 6 says the sum of the interior angles of a polygon is 2880 degrees. So we don't know how many sides the polygon has. That's what we're asked to find. How many sides does this polygon have? So we can use that same formula as on the previous page. And you see it's n we're trying to find, but we know the sum in this case. So 2880 goes in here. And we're trying to solve for n. Now, 2 ways you can solve this now. We could actually expand the 180 into here, but the 180 actually will divide out of both sides of this equation. So we can divide the 2880 and the 180 both by 180. And the purpose of that is so that these divide out, and you see we'll just have n minus 2 on this side. 2880 divided by 180 is 16. And so to find n, now it's not 16 sides. Remember when I showed you there were 6 sides, but we divided into 4 triangles. See, you have to, in order to solve for n, you have to take this 2 over and add it to the 16. So there's really 16 triangles, but there's 18 sides. Remember, the number of sides is always 2 bigger than the number of triangles you can divide it into. So it would be an 18-sided polygon. And one last page, an example. In number 7 here it says determine the values of x and y. So just another example of a diagram where you're asked to find some angles. And it says justify your answers. So justify your answers means to show some evidence of why you're doing what you're doing to find those unknown angles. So I'm going to find x first in this diagram, because I look over in this one and see I've got 2 unknowns. So, but this one, this part of the diagram, I only have 1 unknown, just the x. So that's why I would start with the left-handed 5-sided figure here. Now it's 5 sides, so the interior sum, we would put 5 in place of n. And of course 5 minus 2 is 3. So 3 times 180, there's the 5 angles in here add up to 540 degrees. So in this triangle, this x, and this x, there's 3 x's plus the 2 90s would add up to 540. So this is how I can make an equation. Now, I could have written 90 plus 90. I just changed the two 90s into 180. So 3x's plus 180, the two right angles, adds up to 540. So I take the 180 over and subtract from the 540. And that works out to 360. And we divide by 3, divide 3. So the 3's divide out, and 360 divided by 3 is 120. So these are each 120. Now, this x over here, of course, would be the same as that one. So this is also 120 degrees here. I didn't bother to put them in that figure, but this is what I'm working with now. So you see in this four-sided figure, remember quadrilateral, the interior sum is 360. And so it's the only one that the interior and exterior sums are the same. So we can find y, because y plus 120 plus the 65 plus the 90 adds up to 360. The four angles add to 360. If we add those three angles together, we get 275. And subtract that from the 360 to get y is 85 degrees. And that's the last example.